Kids, okay, so today we are going to look at adding integers without a visual representation. So with that being said, I'm going to throw in some decimals, some fractions today. Your warm up, I asked you to copy that kind of basic review into your notebook. Yes, I know it's been a while since you've been to decimal or fraction town. And we're going to start today with only using fractions with common denominators. I think that's kind of the scariest piece of fractions is getting the common denominator. Then we've got a negative, and then we have to simplify. There's lots of things to do. So everything today with a fraction has a common denominator. With that said, you also can check your work with a calculator. I know it's hard to check with fractions. We'll do more like little warm-ups and things to get you typing fractions into your calculator. And we saw a little bit of that with our geometry formulas, but like I said, we're going to take it really slow. So the first thing I want to show you is a what I call the manual for adding integers. Get to my hover cam. There we go. Okay, so I had the kids copy this into their notebook, and this would be a great place to pause and write it down. Remember, my digital notebook will have this, but this is what I call the instruction manual for adding integers. Now, I don't want you to feel like we're chucking the number line or we're chucking the algebra tiles. That's not necessarily true, but I don't want you to have to depend on them unless you're really unsure. So these are ways to get through these problems without drawing something. Okay, so there's two rules. They either have the same sign, they're either both negative or both positive, or we have one of each side, right? Based on that, the rule is different. If I had two negative numbers, for example, -2 and -4, if I thought about them on a number line, I'd go negative, then I'd go a little more negative, right? Or if I had algebra tiles, I'd have 2 negative tiles and 4 negative tiles, and I would add those tiles together to get 6 negative tiles. That's exactly what this rule says. And I do this, I've done this for years, okay? So I'm gonna ask you, what do we do when the signs are the same? And I always make my kids say back to me, add the number, keep the sign, okay? So we're gonna add the numbers, keep the sign. For example, my question 2 down here, I have 2 of the same sign that I'm adding together. So I'm going to go ahead and label this as a green example. That's why I did that green up there. So the signs are the same. And what do we do when the signs are the same? Add the numbers, keep the sign. So I'm going to add 26 and 5. And then I'm going to keep the sign the same. Negative, right? And again, really daydream about your algebra tiles, what it would look like. And hopefully that is something you feel good about, okay? On the flip side, if they're not the same, remember if they weren't the same with algebra tiles, we were crossing things off and seeing what's left over, that's subtraction. Or on a number line, if we were to go one direction, that was say negative, and if we add a positive, we were kind of reversing our direction, right? Same situation. So there's no real cool like snap thing I'm going to ask you here. If they're different, we subtract their values, big minus small, and then we take the sign of the one there are more of. So for example, question number 1 is are two numbers that have different signs. One is a positive, one is a negative. So I'm going to subtract them. And I always want to subtract big minus small, no matter what order they're in, no matter if they're positive or negative, take whichever one is bigger, the absolute value, and subtract the other one. So I get 8. And then I have to take the sign of the one there are more of. Well, there are more negatives in this problem. So a negative answer. Right? Think about the algebra tiles. I have 12 negatives and 4 positives. After I cross them off, 8 of those negatives remain, right? So we're going to practice these with a few more whole numbers, Then we're going to start looking at decimals and fractions. So for number 3, I just want to make sure I'm recording. I have a bad feeling that I'm not recording. Okay, good. Okay. That's happened before many, many times. Okay, so for this next one, I've got a negative 11 plus 2. So I ask myself, are the signs different or are they the same? They are not the same. So I'm going to subtract their values. 11 minus 2 is 9. And I'm going to take the sign of the one there are more of. There are more negatives in this problem too. So I have a negative number. Okay. All right, let's keep going. Number 4. Do they have the same sign? Yes, they do. And what do we do when the signs are the same? Add the numbers, keep the sign. So I'm going to add 13 and 9. And I'm going to keep the negative sign. All right, next one. Do they have the same sign? Yes or no? No, they do not. And now let's switch it up. I'm going to ask myself, which one are there more of? What's the sign of my answer going to be? Well, I've got 3 negatives, 6 positives. I know it's going to be a little positive answer. In fact, I'm not even going to put a plus sign because that can confuse some people. So then I subtract their values. 6 minus 3, right? I don't care about the order. I always have to do big minus small. And I get 3, positive 3. Last one, the signs are different. They are not the same. There are more negatives this time. So I'm going to put a negative answer. And then 8 minus 3, the difference between them is 5. Negative 5. Okay. Now we're going to start to look at decimals and fractions. So there are a few things I want to remind you of that you should have written down. So I'm going to go very quick. Some stuff. So for decimals, remember the number 1 rule, the only thing in fact that you have to remember is that you need to line up the decimals. Have to. If the place values don't match our number, we're literally adding the wrong values together, the wrong place values. So that's not what we want. When we're reviewing, when we're looking at fractions, we're going to save the get a common denominator section for another day. And all I want to review while we go through problems is how to simplify, change an improper fraction to a mixed number, and how to change a mixed number back to improper. Okay, so let's take a look at some examples. Okay, here we go. Situated. Turn this. You guys can actually. Okay. All right. So the first one we're going to do, this includes all rational numbers. Okay. 7. Let's do a decimal first. So 5.8 plus negative 7.2. So if I ask myself that question, do they have the same sign? Yes or no? They do not have the same sign. So what I'm going to do is subtract their values. Big minus small. Okay. Now again, I liked how I did that before. I'm going to decide if my answer is positive or negative right now before I keep going. So I've got a positive 5.8, negative 7.2. There are more negatives in this problem. So I'm going to have a negative answer right there to start out. Now, when I subtract these decimals, I cannot subtract. I can't do 2 minus 8. Can't do it in this algorithm. So I have to borrow from the 7, make it a 6. Now, I was taught to put the 1 in front of the 2 like that to make it a 12. But a lot of kids I've seen over the last day or so, they cross out the 2 and put a 12 out to the side like that. So as a math teacher, I will accept both. Please don't stress. Whatever works for you, keep doing it. All right, so now I can move along now that I've borrowed. So 12 minus 8 is 4. 6 minus 5 is 1. And I bring my decimal point down. Negative 1.4. Okay. I've noticed, this is just me, like this is one of my bad habits. If I don't put the negative there to begin with, sometimes I forget about it. Like I'll put the number and just forget to chuck the negative on. So I've just learned over the years that's something that's good for me to do first. And it might be for you as well, just an idea. All right, number 8. We're going to go to fraction town. Okay, now again, all of these are common denominators. So the first one, we really aren't going to have to do much at all. You'll see what I mean by that. So we're going to look at negative 5/9 plus negative 2/9. Okay. I'm going to do some fractions with the slash this way and some fractions with it perfectly horizontal, just so you can see both and not get freaked out by either one. All right, so I asked myself that question. Are the signs different? Yes or no? They have the same sign, right? They have the exact same sign. And what do we do when the signs are the same? Add the numbers, keep the sign. It's so much more fun when you guys say it with me. But so I'm going to add the numbers, 5 and 2. I'm going to keep the sign in negative. And then I keep the denominator the same. So let's write that out to the side. Keep the denominator. Okay. And that's it for our first fraction. Okay. It's not that bad. It's just the extra stuff that we sometimes have to do that can be scary, right? All right, so number 9. 1, I'm going to write this one big. 1 1/3 plus negative 2/3. Okay. So it's our first mixed number. Okay. I am always going to encourage you to change every mixed number to improper. There are shortcuts that some of you have learned, but I'm not going to necessarily address them. Okay. If you are good at using them and you know what I'm talking about, you can keep doing it. I'll follow your work. If not, you're going to do what I do. So you did see this on my review page, but we're going to change this to improper. And so I kind of write that C there, right? We're going to multiply 3 times 1. Then we're going to add the numerator 1, and that will create part of our new fraction. So 3 times 1 is 3, plus 1 is 4 over 3. Notice I just keep the denominator. I just bring it right over. All of that calculating was just for the new numerator. And then I'm going to rewrite the rest of the problem. Okay. All right, so we've got a positive and a negative. That means I'm going to subtract their values. 4 minus 2, 2. I'm going to keep the third denominator, or the 2/3, 4/3. I'm going to keep that 3 there. And then I decide if my answer is positive or negative. Well, there are a few more positives, in fact, double the amount of positives than there are negatives, so we're positive 2/3. Okay. Last one. Number 10. Negative 3/4 plus negative 3/4. Okay. All right, so the signs are the same. What do we do when the signs are the same? Add the numbers, keep the sign. You see that? Is that still cool anymore? Is that the cool move? Or is it like TikToking? Whatever you guys do on there. I don't know. That's like the first time I felt super old, is seeing people just like dancing around the halls in class. It's very bizarre. Very bizarre. All right, so I have the same sign. I'm going to add the numbers, keep the sign. You have negative 6/4, right? 3 plus 3, chuck the negative in front. So here's where I am definitely not done yet, okay? I have an improper fraction, meaning that the number on the top, the numerator, is larger than the denominator, and that's not okay. In fact, its name literally says it's not proper. It is an improper fraction, okay? So we're going to change it. Again, this is on that review sheet that we should have written down for our warm-up, but here's how we do it. I'm going to divide 6 by 4. How many times does 4 go into the number 6? Well, it goes in only one whole time. Go. And if I subtract 4, if I put that 1 4 in, there are 2 wholes or 2 ones left over, right? In fact, it's not 2 ones, it's 2 fourths, right? The denominator stays the same. That should be like the no questions asked piece of the puzzle. So again, the whole number 1 came from the whole 4 that fit into that 6. The 2 came from the leftover. And then I almost forgot, it was a negative improper fraction. So it's a negative mixed number too. And we're still not done because 2 fourths can be simplified. There is a number that fits into both 2 and 4, and that's 2. So I'm going to divide by 2. The negative 1 stays. I did nothing to it. The only thing I'm messing with is the 2 fourths. 2 divided by 2 is 1. 4 divided by 2 is 2. And there is my final answer of negative 1.5. Okay. So again, I know that it can be very scary to see fractions and decimals come back in with negatives. But today, common denominators only. I really want you to focus on the negative rules and simplifying, converting mixed to improper. And guys, if you have trouble with it, if I see that on the Big Ideas assignment, we will do more of it. But this is one of those things I am counting on you to please ask questions or advocate for yourself. I mean, I can talk all day long, I really can, but unless you ask me a specific question, if you're unsure what you got wrong, I can see your work on the camera, like let's do what we need to do so I can really help you identify your mistakes. Because what I find, you guys, is most of the time, it is something really small. Like a lot of kids have all this stress about it because they don't, nobody wants to be wrong, right? I think Teresa called me out on a mistake I made on a set of notes one time. It happens. We're human, right? It happens. It will happen. I promise you it will happen. But you got to try and find that mistake and let me help you, okay? For real. You got to stand up for yourself and let me know if you have any questions, okay? Counting on you. Counting on you. I'll see you in a little bit. Bye.